Today we're going to put together the next section, section 4.7, which is the law of sines. Law of sines is going to be a tool that we're going to be using to solve a triangle. And remember what we said earlier, to solve a triangle is to find all the missing pieces of the triangle. When we label the triangles, we talked about this earlier, that we label the sides with capital letters, or excuse me, the angles with capital letters, A, B, and C, and the sides that are opposite get to be the smaller version. So the big letters are the angles, small letters are going to be the sides, and they'll always be lining up opposite of each other. We're going to be working with different conditions, what information that we're given, information that we're not given, and how do we work with all these pieces together to solve the triangle. There are a couple things that, even though we're dealing with a non-right triangle, that we can still use. We obviously can't use the sine, cosine, tangent that came from the SOHCAHTOA because we don't have a right triangle. Something may show up, but not necessarily. We do know that angle A plus angle B plus angle C is still going to be equal to 180 degrees, still a triangle. And we still know that two of the shorter sides have to be, when you add two of the shorter sides, that have to add up to be larger than the long side. So in this case, if A is my long side, then I know that B plus C has to be greater than A. If it's not going to be a triangle if that situation doesn't hold true. Well, one of the things, in order to get to the law of sines, we need to talk about the area of the triangle. Area of a triangle is still 1/2 base times height. Now the way that I've got this set up here, it looks like this A, we're going to call this our base. But we don't have a height in this triangle yet. So we got to give us our height, and the height of the triangle is when you drop an altitude, and by definition an altitude makes a 90-degree angle. We're going to call this side length X because we can't call it A. A is the entire length across the base. We'll call this X, which means that this length over here will be A minus X. And here, this is our height of the triangle. Well, if we know that this is true, we can take the right triangles that are created here, and we could say that the sine of angle C is equal to H over B. We could also say that the sine of angle B is equal to H over C. Now, with a little bit of moving around with each one of these, we could take this first equation and say that H is equal to B times the sine of C by solving for H. And if we solve for H in the other equation, H will equal C times the sine of B. Now, how that helps us out is, in that area formula, my area of the triangle was equal to 1/2 times the base. Now the base in this case, I know that in here when we wrote that we said B, but the base is length A times H. Now the height in this case, we came up with two expressions. We said that that could be equal to B times the sine of C, or we could say 1/2 times the base times the height, which was C times the sine of B. Now, it just so happens that if we played around with that triangle just a little bit and maybe changed its orientation or dropped another height in there, we'd be able to come up with a third relationship. So we got 1/2 A times the sine times B times the sine of C. We got 1/2 times A times C times the sine of B. And the third relationship that we can go through is 1/2 B times C times the sine of A. Now that's going to be true for all three of them. You'll just have to trust me on that third equation, but it does hold true. You've got two sides and an angle. Now, one thing that's special with this, and we're going to go take a look real quick here. Let me erase some of the stuff that's in there. Take a look at the information that you've got from your triangle. When you've got two sides, A and B, you work with angle C. When you have sides A and C, you work with angle B. And when you have sides B and C, you work with angle A. In each of those cases, that is two sides, and it's included angle. two sides in this included angle. That angle is in between those two sides. And if we know those lengths of those two sides and the angle that's in between them, we could find the area of the triangle. Now I mentioned that we were going to be using a tool to solve the triangles and to find all the missing pieces, and that certainly doesn't help us find all the missing pieces because all we're doing is messing with the area. Well, I'm going to take this formula and mathematically we're going to, since it's an equation, I can do the same thing to all three equations and not change them. We've talked about that as you were solving equations before. What I'm going to do is I'm going to divide every single equation by 1/2 ABC. Now you may be wondering why on earth we'd want to do something like that. And something interesting is going to happen as we go through that. Now we notice that when I divide everything by the same thing, I'm not changing the problem. What ends up happening though, my 1/2s become 1, A over A is 1, and B over B is 1. So I get the sine of C divided by little c is the same as, and I got some other things that come out to be 1 in this case, and I'm left with the sine of B over little b. And in the third one, some things become 1, and we're left with the sine of A divided by little a. And what we're left with here is a relationship between the sides and their angles, and this right here is called the law of sines. And using this set of relationships,